All right, folks, welcome. We're going to get started here. The only big announcement I have is Friday you have a quiz. Set some sort of a reminder for yourself because there's no classes that day. So I don't know if you're planning on doing something or what's going on with people, but you got to take the quiz Friday at some point. So make sure you take care of it. All right. So there's two more major topics I need to talk with you about today, and then we'll end the class with kind of a review of a graphing problem. Okay. So you need to be able to evaluate certain logarithms without a calculator. That's the expectation as you enter pre-calculus. So we're going to talk about that for a few minutes. Evaluate without a calculator. In other words, you could do some writing, very minimal amount of writing, but really, this is something where I don't really need to see work from you for these. Right? These are problems that you are meant to do in your head. That is the goal. That should be your goal. So I'm going to start with log base 3 of 81. Okay. Now, of course, some of you might not even know what that is, which is fine because we're starting this really. What I'm going to suggest to you is that you introduce your favorite letter to the problem. You make an equation out of this. So I'm going to use Z. I'm going to say that the answer to this is Z. Now you can use what we talked about last time. You can take this thing and you can translate it to its exponential form. That's what we did at the beginning of the last class. We went from exponential to logarithmic and vice versa. So I'm going from log to exponential. It would be 3 to the Z equals 81. Three to the Z is equal to 81. And if it's still a problem, if you still don't see it from here, you're going to have each side of the equation is going to be powers of the same number, at least for problems like this, okay, that you're expected to do without a calculator. So 81 is 3 to the 4th power. So I rewrite that. And now the bases are the same, so they kind of just disappear, and you have an equation made entirely from the exponents. So Z equals 4. And that's it. So your brain has to get used to the idea of what a logarithm is doing. The base number, right, it's asking you 3 to what power gives you 81. That's the problem. That's it. 3 to what power gives you 81? The answer is 4. If you need to go through this work to get it, so be it. All right, let's do another one. Let's do the log base 25 of 5. Again, I'm going to say that's equal to Z. I'm going to call my answer Z. I'm going to translate this. Now, when you see this in my work, and this is important because this is going to come up a lot in the next few weeks. When you see this kind of squared off arrow that I'm doing, that is my notation to translate to the other format. So I'm going from logarithmic to exponential. I'm not going to write the word translate. Okay, you need to know that that's what I'm talking about. So I'm translating it from a log to an exponential. It would be 25 to the Z equals 5. And both sides are powers of 5. So 25 is 5 squared. So I rewrite that. 5 is just 5 to the first. And on the left-hand side, I have the power of a power property. So I multiply the exponents. That gives me 5 to the 2z equals 5 to the first. And much like the last problem, the bases are the same, so they drop off, and I'm just left with 2z is equal to 1. And I solve that. So z is equal to 1/2. And this should make sense to you because it's asking 25 to what power is equal to 5? Well, you know, the square root of 25 is 5. And square root means 1/2 power. We did that in the last chapter. It's 25 to the 1/2 is equal to 5. One more note before we do another one. When you're taking the log, and all these numbers that I have written right now are integers, right? 3 is an integer, 81 is an integer, 25 is an integer, 5 is an integer. If that's what's going on in the problem, if the base number becomes, if that number needs to be larger to get to 81, that means your answer is going to be above 1. 25 is getting smaller to become 5. So your answer is going to be a fraction between 0 and 1. And that will always happen. Let's do another one. Let's do log base 7 of 1. Log base 7 of 1. Z. I'm going to translate this. 7 to the z power equals 1. And there is no fancy rewriting of it. You need to know that anything to the 0 power is equal to 1. That's it. Z is 0. So either you know that fact or you don't. I'm going to give you 3 to try real quick. So we'll call this D, E, and F. I want you to do, let's do the log base E of 0. Let's do the log base 15 of the cube root of 15. And the log base 1/3 of 9. All right, I'm going to set the timer, 3 problems, 3 minutes. Go ahead and try it. Okay, so again, I'm just going to say that the answer is Z for all these. Translate to exponential e to the z power equals 0. So what can you raise e to get 0 back? The answer is you can't. You can't raise something, and it doesn't matter that it happens to be e. I could have any number I want here, 11, 50, whatever. You can't take a number, raise it to a power, and get back nothing. It's not going to just disappear when you raise it to a power. So this is undefined, this one. Next one, translate it, 15 to the z equals the cube root of 15. The cube root of 15 is 15 to the 1/3. That's what cube root means. And now I just have the equation of the exponents, right? The 15s disappear. Z is equal to 1/3. And that's it. It's done. The last one, translate it. I get 1/3 to the z power equals 9. So both sides are powers of 3. 1/3 is 3 to the -1. So I'll rewrite that. 9 is 3 squared. And I've got, on the left-hand side, power of a power property. So that would be 3 to the -1z equals 3 squared. So -1z, you can just write -z equals 2. So z is equal to -2. Now there's 3 patterns that have shown up, some of these, and I want to talk about those 3 patterns, and then we'll move on to the next topic. And again, these are patterns to help you do mental math with these. We're going to encounter logarithms that can't be done mentally next week and the week after. All right, so I'm just going to title this 3 widely used logarithms. And I'll just give you a quick example of each one. The first one is, and I'm going to use just a random letter. I'll use m, okay? Log base m of m. Log base m of m. What it's asking you is m to what power equals m? The answer is 1 for any number that you put there. Okay? So if you had, let's say, the log base 17 of 17 equals 1. Again, you can't defy the definition. Like, you can't use negative numbers because we talked about that last time. The base of the logarithm has to be positive. The base can't be 1. All those rules are still in effect. Next one would be the log base m of 1 equals 0. And we did one like that. I think it was example C. Right? But I can do the log base, let's say 11 of 1. It's asking me 11 to what power equals 1? 0. 11 to the 0 power. And then the last one, the log base m of m to the n. The log base m of m to the n equals n. And you can see an example of that in, what was that, example E. I'll write it out here and show you what I'm talking about. We had the log base 15 of the cube root of 15, right? That was the original problem. If you take your first step here is just to rewrite it, and you say, oh, I know cube root. Cube root means 1/3 power. So you rewrite it as 15 to the 1/3. Now you see it fits the mold. The log base 15 of 15 to the 1/3, and our answer was indeed 1/3. So it does save you some time if you remember these, instead of writing out the long way that we've been doing, writing it out, translating it. All right, these show up a lot. All right, next topic is inverses. I mentioned it in the last class. We actually graphed an exponential function and its inverse. I believe we did 3 to the x with log base 3 of x. But I never went through the process of, showing you the algebra that backs it up. So we're going to do that today, and we'll do some others. We're going to title this Find the Inverse of the Function. And again, I'll start with something that we can do. Okay. So I'm going to do the log base 5 of x. Now, this is a parent function. There's nothing like wild going on with it. Your reasoning can be the same as we talked about last time, right? I know if I have a log function, then its inverse is the exponential function with the same base, which would be 5 to the x. Now, how do we get there? All the steps that we did on finding inverses back in the beginning of chapter 7. The first step was rewrite it as y equals. Switch x and y. And then solve the resulting equation for y. And that's where it gets tricky. Now, they won't show you this step in any book, but I'm going to rewrite this equation. I'm going to switch the left-hand side and the right-hand side. So I'm going to write log base 5 of y on this side and x on that side. The reason I'm doing it is every problem that we've done so far in this unit, I've had the log expression on the left. So now when I go and I translate it, it should be easier for your brain to accept. All right, translating this gives me 5 to the x power equals y. And that's it, I'm done. I can rewrite it in, inverse function notation, f inverse of x, remember that? But log base 5 of x and 5 to the x, they are inverses of each other. And that's the algebra to prove it. Unfortunately, a lot of the problems are not that easy. Because this is just parent function. When you start having functions that are moved around and translated left and up and all that kind of stuff, then there's more work, more steps. So let's do one of those. We'll do this next one together as well, and then I'll let you try one. Let's do f of x equals the natural log of x plus 3 and then plus 1 at the end of it. Right. And I'm throwing this in here because I'm going to try to keep reminding you here that natural log means log base e. I gave you that in the last set of notes. So you should, anytime you see natural log, ln, for now, for the foreseeable future, you should rewrite it as log base e. So I'm going to do that as my first step. Okay, log base e. Now I go through, okay, rewrite it as y equals. Switch x and y. Now, in order for you to do this translating business here, you have to have the log expression by itself. When I look at this, that's not the situation yet. I got to get this 1 out of here. So I'm going to subtract it, both sides. That's going to give me x minus 1 equals log base c of y plus 3. And again, I'm going to switch the sides. So I'm going to just swap the sides. Log base c of y plus 3 equals x minus 1. Now I'm going to slow it down even further here for a second, because this is the critical step. If you can't do this step, you're not going to be able to do any of the problems. If I look back to example A, and I'm going to color code this. The translating step is you take the base, which I'll put in blue, okay? You take the base, you raise it to what's on the other side. So the blue to the pink power equals the purple. And that's what I have here. The blue, right? 5 to the x equals y. And that's what I wrote on the next line. If you duplicate that logic over here, the base is blue, raised to what's on the other side is the pink, gives you all this stuff, which is the purple. That's the pattern every time. So if you need to use colors to organize your work and to remind you of that pattern, do it. Because the next step is that translating step. You have to do it. So it's e to the x minus 1 equals y plus 3. And then you subtract the 3 over, and you're done. All right, so it would be e to the x minus 1 minus 3 equals y, which I'm going to write as f inverse of x. Okay, and then that's it. All right, I'm going to give you one to try. I'll leave this up here on the right here. Okay. This will be example C. F of x equals 2 times the log base 3 of 5x plus 1, the quantity 5x plus 1. So the 5x plus 1 is in parentheses, okay, and there's nothing after that. I'm going to give you 2 minutes to work on this. I'll set the timer. Try it out. Okay. So we got the rewrite as y equals. Switch x and y. And now solve this for y. I want to isolate the log expression. There's no other terms on that side, but I do have this 2 as a coefficient. I don't want that there. I'm going to divide by 2. So I get x over 2 equals the log base 3 of 5y plus 1. Now, I'm not going to rewrite it, like I'm not going to switch sides here, okay? Kind of like what I did here. I switched the left-hand side with the right-hand side. But I will color code it like I did the last one. So you have the base, which is 3, raised to what's on the other side of the equation, which is x over 2, has to give you all this stuff here in purple. So 3 to the x over 2 equals 5y plus 1. Subtract the 1. 3 to the x over 2 minus 1 equals 5y. And then divide by 5. And then that's it. It's f inverse of x. 3 to the x over 2 minus 1 all over 5 is f inverse of x. So now at this stage of the notes here, you can now do all of the homework problems. There shouldn't be anything stopping you from doing any of the homework now. So we're going to spend the last portion of class here, we're going to review just the tactics for graphing. We'll just do one problem. All right, so we're going to do sketch. And of course, I want the domain, the range, the asymptote, all that stuff as usual. We're going to say the function is f of x equals, let's do -1/2 times the natural log of x plus 4 plus 6. And I will remind you here, you want to rewrite it as log base e. Okay, well, -1/2 log base e of x plus 4 plus 6. And remember, these are going to take 3 tables. 3. You have the parent exponential. Parent exponential. Then you're going to have the parent logarithmic. Then you're going to talk about your actions that are happening within the function. Apply those actions to this parent log table, and that'll give you your final table. That is the style. I'm telling you this again because last week people are handing me in homework. They're not doing it the way I asked. If you don't do it the way I ask, you're not going to get higher than a 50 on the homework. I'm telling you. You need to do it this way. I'm going to give you, what time is it? I'll give you 4 minutes. I'll give you 4 minutes to work on it. Okay. So your first table is your parent exponential. It has the same base as this. So this is a base e log. So you want y equals e to the x. You could generate it on your own. I told you that this is probably a good one to memorize because you're going to have to use it every time you do a graph involving e or a graph involving a natural logarithm. So it's 0.13, 0.37, 1, 2.71, 7.39. You take that table and you flip the columns, okay, because it's the parent logarithm is the inverse. That is going to be for log base e of x, which is natural logarithm. Switch the columns. Your actions, you look at your equation. You've got the plus 4 in here. That means you're going to the left 4. Left 4, that means you're going to be subtracting 4 from the x column to do that. The other actions are the combined action of the compression and the up-down movement. So you have to multiply, right? This is going to be compression by -1/2 and then up 6. That's multiplied by -1/2. Then add 6 to the numbers in the right column. And I did this. You have -3.87, -3.63, -3, -1.29, and 3.39. And in the y column, it starts at 7 and it goes down by 1/2. So 7, 6.5, 6, 5.5, 5. So you should have something very close to those. Now you make your decision on what size your graph needs to be. I can get away with just going up to 7, so that's what I'm going to do over here. First thing you should put on your graph is your asymptote. Asymptotes for any kind of a logarithmic function corresponds with the left-right movement. So that's here, left 4. So I move left 4, the asymptote. That is the line x equals -4. X equals -4. And then I'll start plotting my points. So -3.87, comma 7, it's way up here. -3.63, 6.5. -3.6. And so they're pretty bunched up right there. You can't really see the bend yet until you get the other two in there. -1.29, 5.5. And then 3.39, comma 5 is over here. So it's going almost vertical, right? As you go to the left, it's going up and it's kind of squeezing in towards the asymptote, pushing in towards it. And as you go to the right, it's slowly going down, slowly. Eventually, it's gonna cross it over the x-axis, way down the road somewhere, but it is gonna cross it. Domain range asymptote, we'll put that on there. We already have the asymptote, x equals -4. The range for every log function is all reals. And then the domain, you just have to look at the picture. The entire graph is to the right of -4. So x is greater than -4. Make sure you don't forget to take your quiz Friday. All right, make whatever whatever alarm you need to set. Homework is still due Sunday. I'll send the video out soon. But that's it. You're free to go. Come to conference period if you have questions. Have a good day.